This is your video for finding missing links with similar triangles. We are going to focus on two situations that create similar triangles. The first one is indirect measurement, and the second one is overlapping triangles. Please fill in this information. Indirect measurement will happen in two different situations, and we will focus on those first. The first opportunity for indirect measurement is with the use of mirrors, or a mirror. And so in this situation, we're going to place a mirror on the ground right here, and you're going to have a tall tree over here, and this person is going to back away from the mirror until they can see in the mirror, when they look down, the very tip top of the tree. And they'll continue to back up until again they can see that. And at that point they would stand perfectly straight, perpendicular to the ground, and so their body would form a right angle with the ground. The tree is going to form a right angle with the ground. And then the angle from the mirror for the person's eyes to the ground and for the mirror to the top of the tree would be the same angle. And so if you can see the two triangles in this picture here, they would be similar triangles by angle, angle. And so we could find the height or missing pieces of the triangles if we had 3 pieces. We just need to have 3 of the 6 sides, and you could find the rest using proportions. And so let's go ahead and look at a situation like that in this little video.
We can use similar triangles to measure a height of something tall. The way that we do this is by having someone go outside and placing a mirror on the ground. And what they do is they back up until, in the mirror, they can see only the very top of what they're trying to measure. So what we're going to do is we're going to create 2 similar triangles using the angle-angle shortcut. These angles of light bouncing off that mirror are congruent. That's a property. And we can also say that the building, if it was built correctly, will go up at a 90-degree angle, and that the person measuring it will stand at a 90-degree angle. So we have 2 triangles here, which I'll redraw. And again, this is not to scale. And if that person is 5 feet tall, and if they stand 7 feet away from the mirror, and if the distance between the mirror and the building is 49 feet, then we can call the building's height x.
So let's go ahead and model that in this example. Which I rearranged the order here. So let's go ahead and call this example 1. And in that video we had again 5, 7, and 49. So we have someone here that is 5 feet tall. Here's our mirror on the ground. They are 7 feet away from the mirror and 49 feet away from the mirror is 49 feet away from the base of this building over here. And so we're going to call the height of this building x. And so we're going to set up a proportion just like we have been. Now these 2 triangles would be reflections of each other. So the 5 over 7 set up in a proportion to solve, because we have similar triangles, you know the sides are proportional, we would have x over 49. And so to solve this problem, we're going to set our cross products equal to each other. And so 5 times 49 equals 7 times x. So 5 times 49 is 245 equals 7x. And then to solve, we would, of course, divide by 7. And we could see then that the height of that building would be 35 feet tall. The other situation where we're going to use indirect measurement with similar triangles is a sun model. And let's take a look at what that might look like in another video.
We can use what we know about similar triangles to find the height of this tree. Now the way that we're going to do this is by using what we know about the angle of the sun. If we measured the length of a shadow at the exact same time, then that angle from the sun would be congruent in both of these triangles. And if the tree is perpendicular to the ground, and if the person is standing perpendicular to the ground, then we'll have an angle-angle shortcut which will allow us to find the height of the object. So let's go back to our problem. And we've already measured the person's height, which was 175 centimeters, and the person's shadow, which was 200. So if I draw in that triangle, we'll have 175 and 200. And I'm going to write that this is a right angle. And I know that this angle up here will be congruent to the angle formed by the tip of the tree and the sun. So we're going to have another triangle over here.
So let's go ahead and model that here. So the second way that we're going to use indirect measurement is with the sun creating a shadow on the ground. And so this kind of relates to our unit problem, what is the length of a shadow? But in this particular problem, we have a 175 centimeter height person. We have their 200 centimeter length shadow, and the tree was creating a 600 length or centimeter shadow, and we don't know the height of the tree. And so in our unit problem though, we want to know what the length of the shadow is without measuring it. And so this situation here, again, we had similar angles from the sun. Both items were 90 degrees to the ground, so these are similar triangles. And so in this next, here very soon, we will solve the unit problem, and we will use that idea of similar triangles in the model that we drew at the beginning of the unit. So again, let's go ahead and solve this with similar triangle relationships. We know the sides are proportional. So 175 centimeters over x would be equal to 200 over 600. We could have wrote 175 over 200 equaled x over 600, but either way, they could be set up like this. And we would, again, have cross products set equal to each other. So we're going to have 200x equals, let's see here, 175 times 600, so 105,000, big number. And we'll then divide by 200 to get x by itself, and the height of this item here, this tree, is 525 centimeters tall. And so the purpose of this situation is we could measure things on the ground, but we usually can't measure the height of the this vertical distance, especially on a tree. And so this indirect measurement would be very useful in that situation. And so let's go ahead and leave this blank, and let's go on to example 3 here. So those were our two situations for using indirect measurement with non-overlapping triangles. And so this problem here is a review of what we've been looking at, like non-application problems. So here are two triangles, the angles are similar, and so let's set up our ratios. So 2x plus 1 over 20, we know would equal 7 over 13. We'd set cross products equal to each other. And so we know that 20 times 7 is 140, and we're going to take 13 times both those items. So remember, 13 times that whole expression up there, you might want to set that up in parentheses so that you can distribute. So we'd get 26x plus 13 equal to 140. We would subtract 13 from both sides. And then divide by 26, and x would be approximately 4.9 if we rounded to the nearest tenth. My calculator is getting 4.8846. And so the other situation here that we wrote down at the beginning would be, if you remember, overlapping triangles. And so that's kind of a newer idea for us. So let's look at example 4 together. So overlapping triangles, you'd have a problem that looked about like this. And so inside those overlapping, inside this large triangle, I have a smaller triangle here. Okay, and that triangle would be similar to the larger triangle because they're both drawn in at a 90-degree angle, and they're sharing this angle in the corner here. And so to get the proper answer for x, I would like you to draw out these two triangles and understand how long this side actually is. So this is my smaller triangle. I have a length of 7 and a length of x. And on my large triangle, I have a 15 here. And I need you to understand that the distance from here to here is 6, and the whole length is going to be x plus 6. So that whole entire length together. And so now when I set up my proportion, now I have these two drawn out from my overlapping triangle. I could say 7 over 15 equals x over 6 plus x. And same setup here, cross products equal each other, so I'm going to get 15x, and then 7 times 6 is 42, and 7 times x is 7x. So 7 times both of those items there. And solving this problem, I would subtract 7 from both sides. And then I need to divide by 8. And 42 divided by 8 is 5.25. All right, example number 5, we have, again, two overlapping triangles here. The small triangle is x and 5, and the large triangle is a whole length of 26 and this length of 18. So sometimes, like in example 4, you had to add the two chunks together. This one was already separated out for us. And this is not like 26 minus x, it's just this whole length is 26. And so x over 26 would equal 5 over 18. And so 5 times 26 is 130. So we're going to have 18x equals 130. And dividing both sides by 18, we would get 7.2 repeating. So when you are working on your overlapping triangle worksheet, I highly recommend drawing your two triangles separate from the problem given. Let's look at a couple word problems here, and let's see if we can figure out if we should set up overlapping triangles or two separate triangles. So on this particular problem here, we have a lamp is 20 meters away from a bush, and the bush is 2 meters tall. And the height of the light is 10 meters. Find the length of the shadow cast by the bush. So the lamp is a certain distance away from the bush, and so this is sounding like a situation where we will have the overlapping triangles. So the lamp itself, okay, is 20 meters away from a bush, and the bush is 2 meters tall, and the height of the light is 10. So this lamp is 10 tall, and we want to find the length of the shadow that would be cast off of this bush. And so that then would be our two triangles that are overlapping. So the height of the bush is 2, the distance from the bottom of the bush to the light is 20, and so we want to know what is this length here, this length of the shadow. So again, drawing two separate triangles would help us understand the actual sides of the two shapes. And so the smaller triangle, we have 2 and x. The large triangle is going to be a 10, but the bottom's going to be x plus 20 because we don't know this length and we know here. And so to solve this problem now, we would have 2 over 10 would equal x over x plus 20. And so we would want to set cross products equal to each other again. So 2 times our x plus 20 is going to equal 10x. Subtract 2x from both sides and divide by 8, and then that tells us that the length of the shadow then was going to be 5 meters long. Let's go ahead and look at number 7. So an 8-foot tall bush casts a 4-foot shadow. So an 8-foot tall bush that has a 4-foot shadow. At the same time, a tree of an unknown height casts a 10-foot shadow. So we don't know how tall this tree is, but we do know that it has a 10-foot shadow. And so this, reading this problem, I see that the situations are using the shadows and they're not overlapping. And so you have to be able to draw the picture according to the scenario. Overlapping or not, and this would be non-overlapping problem to solve. And then we would very quickly be ready to set up our ratios here, 8 over 4, x over 10. Set cross products equal to each other. And divide by 4. And we could see that the tree would be 20 feet tall. That concludes your examples, and now you can complete the worksheets for practice.